In today's video, I'll be sharing with you knurling done parametrically inside of Grasshopper. So I'll be going over all of the steps in detail. You'll see from the beginning on how to create the subdivisions and create the knurling. And at the end, we have the ability to apply this to any surface. All right, so the first thing that we'll do is bring in a cylinder. So let's go here to a perspective view. We'll go here to a cylinder. And then the base input is going to be the origin, so we don't have to plug anything in. Then the radius, let's go here and plug in a slider. I created this one of 15. The length, we'll copy the slider and then plug this into the length. So all we've done is created this parametrically using a cylinder and both the radius and length input to change the size. Now we're creating this fully parametrically. This way, this will be like an example. And then later on, if you have a use case for when you want to use this, then you can apply it to any surface. So now with the cylinder, let's go here and divide it using two components, isotrim and divide domain squared. The way these are plugged in is the segments goes into the domain and the cylinder or surface, which I do like to use this component. This way we can change this surface from a cylinder to be on anything. And the surface will go into the surface input and the domain input. Now we can hide both of these. And notice that in the U and V count, we have 10. So let's change this. Let's go to a slider of 12 in the U and 12 in the V count. Notice that, we can change the density. Okay, great. Now the next step is to create the knurling because we have the base geometry. Notice that now all we have to do is kind of create this pyramid, but there are a few steps that we need to take care of before that. So first, we need the center of each panel. So we can either bring in a centroid or using evaluate surface, we can use the surface as a surface input. And then the point is going to be exactly in the middle. So we'll do quotation marks 0.5, comma 0.5. Which means it will be exactly in the center, but we do need to reparameterize all of these panels so we get the center of each. Now I will hide this because it kind of gets in the way, but using this point, we can scale these surfaces relative to each center point. And the factor is going to be a number between 0 and 1, because 0, it disappears, 1 is the same, but we do want it to be smaller. So I'll do 0.5. Then notice that we can change this. And now we're going to take this geometry and move it relative to the normal. So when we bring this back, all of these have a plane and a normal. So what we'll do here is move the geometry. So these as the geometry input. And the motion, notice that they all move up, is going to be using an amplitude, because each direction is different relative to its frame. So we'll go here to normal as the vector, and then the amplitude, we can use a slider. So now we've moved them out, we've scaled them down and then moved them out. Now on this one, These are scaled down by 0.374, but now we need to create a scale down by 1, which means it's the same size, and we can internalize this data. So we know this is 1. And now we can do this one and this one lofted together. But we need to graft this and graft this. So using the original surface as 1, and then this one as 0.5 and moved out, notice that now we have the knurling taken care of, which is this pyramid that goes into this one, and we can change the depth of it. We can change the subdivisions. We can also change the scale amount. Okay. So now let's join this, the lofted part, and the end caps. And to be able to see everything, let's just go here to flatten the input. So this is joined as one open VREP, and we can use a custom preview to see the color swatch, or to see this with some material. So let's recap on what we did here, because I've gone through some of these fairly quickly, and I like to recap to make sure that you see everything that we did here. So let's first label this, call this scale. We'll call this offset. This is going to be the radius, height, the U and V count, this one, we can internalize it. And when you internalize it, notice that it unplugs it, but it places it inside. So this way we don't change this number, because that's a consistent number that we want to keep. Let's organize this a little bit. Scale, offset, and then the output here. So I'll use a geometry component, and this as the input. Okay. So let's recap. Like I said, sorry I was just cleaning this up. I want to make sure to have it clean for you guys. And if you get stuck somewhere, you're like, hey, I don't even, I'm so new, I don't know how this works. You can download this for a limited time on my website, so you can play around with it and see how you can use this. So let's start. Starting by subdividing it. Then we use this to get basically the center point and the normal, so we can move these panels out. So that's what we did, is scaled them down by this amount. Then using the ones that were moved out with amplitude, so with this one, we can now loft together the outside, the small panels that are the originals, and then the moved out ones. And then here we have the knurling. The great thing about this is we can go back here and we can change the number of subdivisions in the U or V, depending on how your surface is subdivided. And then here, the scale might be a little bit smaller. and this is the output. All right, so now let's use the script here within Rhino so you can understand how this works. So let's say here inside of Rhino, I'll go and create a cylinder. And I'll even rotate it this way. Let's go to shaded mode. So now in here, let's say I want to do the knurling right in the middle. So what I'll do is first take this, create a box relative to the center, and just, let's say, pick this. Now I'll take this, copy it, and then do Boolean intersection with this. So now we have the poly surface, then the original one. I'll hide it, and I'll get rid of this side and this side. Now I'll take this surface and bring it into Grasshopper. So I'll go to Surface, set one surface, and then use this surface as the input. It does reference the original one, so maybe there's something else that we could do here. So let's go back. Let's say we want the knurling in the middle. Let's do it like this. So I'll do duplicate edge, and then let's say move it in here, and then mirror it to the other side. We'll loft these two, and then select that surface and use it here as a surface input. So let's go to set one surface. And now in here, we can change the knurling depending on how many subdivisions you want in the U or V. So notice that what we're doing here is basically combining both Rhino, which is, typical 3D modeling, and then some programming for some of the details that we can add. So here, notice that everything is based off of this rectangle, so we can obviously move this to one side or the other. And then at the end, what you could do is go here, go to bake, now we can take these two, I'll just move them to the side, copy them. And now with this one, which is a solid, we'll do cap. And then here, we'll do Boolean union. So what we've done here is place the exact knurling right on the geometry, and this could then be taken into a 3D printer and printed. So let's go here into rendered mode so you can see it. And so that concludes the tutorial. What we've done is basically programmed the design based off of the cylinder, but also have the ability here to use any other surface to apply that to. So let's go here to clear values on that one. And yeah, I'll have this available. If you have any questions, let me know. And with that being said, hopefully you learned a little bit more on parametric design, and I hope to see you in the next one.